All right, imagine a library where the librarian is, well, a mind reader. Instead of searching by title or author, you just describe the feeling or the idea of the book you want, and they just get it. They understand context. That, in a nutshell, is the magic we're unpacking today. We're talking about vector databases, the engine behind the smartest AI you're already using every single day.
So here's our roadmap. First, we'll look at why the old way of searching just doesn't cut it anymore. Then, we'll dive into the secret language AI uses to understand us. After that, we'll see exactly how our magic library works its wonders. We'll look at where you see this stuff in the real world, check out the tools developers use to build it, and finally, peek into what the future holds. Let's get started.
Okay, so first things first. Before we can really appreciate just how brilliant this new solution is, we have to understand the problem it solved. And for a long, long time, the biggest problem with search was that computers were just incredibly literal. You've definitely experienced this, right? You type affordable smartphone into a search bar, and the results show you things like budget phones or cheap handsets. How in the world does it know that you mean the same thing? Because believe me, the old systems, they had absolutely no clue. That simple bit of everyday magic just wasn't possible. See, the old library, a traditional database, was a stickler for the rules. It only searched for the exact words you typed. If affordable smartphone wasn't written down verbatim, you got nothing. Zip. But our magic library, the one powered by vector search, it gets the concept. It knows that affordable, budget, and cheap all kind of live in the same neighborhood of meaning. It's searching for your intent, not just your specific keywords. And that changes everything. So how does it pull this off? How does it understand meaning? Well, AI has its own secret language. It's a way of translating all of our messy, nuanced human ideas into the clean, crisp, and cold logic of mathematics. This is really the key to the whole thing. And that secret language, it's called a vector embedding. Now, that sounds super technical, but the idea is actually pretty straightforward. It's about turning any piece of data, a word, a sentence, a picture, you name it, into a big list of numbers. But here's the kicker. It's not a random list. That list of numbers acts like a coordinate, a very specific address, and a huge, multidimensional map of meaning. And this is what it actually looks like. Yeah, just a bunch of numbers. To a computer, this is the concept of an affordable smartphone. It might not look like much to our eyes, but for an AI, this vector captures the essence, the context, and all the relationships of that idea. It's basically the DNA of meaning. So once you've mapped everything out, something amazing happens. Things with similar meanings naturally cluster together. The vectors for apple fruit and mango fruit are going to be practically neighbors on this map. But apple fruit and car engine, they'll be on completely different continents. It's a simple but powerful rule. In this space, proximity is meaning.
Okay, so we've got these numerical fingerprints for every concept imaginable. How does our magic library, the vector database, actually use them to find what we're looking for at, lightning speed?
It's actually a really elegant three-step dance. First, an AI model chews through all of your raw data and converts it all into those vector embeddings we talked about. Second, the vector database takes those millions or even billions of vectors and stores them, indexing them in a really clever way. And finally, when you ask a question, your question also gets turned into a vector. The database then has just one job: find its nearest neighbors, the other vectors that are closest to it on the map. And this whole Find My Neighbor thing happens incredibly fast. That's thanks to some clever math and algorithms like cosine similarity. You don't need to be a math whiz, but essentially, these are just hyper-efficient ways of calculating the distance and angle between two vectors. The closer they are, the more similar they are in meaning. It's this efficiency that makes the whole process feel instant. All right, let's pull this out of the abstract and into the real world, because this technology isn't some science fiction concept coming in the distant future. No, it's already here, running quietly behind the scenes of the apps and services you use every single day. Think about it. When Netflix suggests a movie because it has a similar vibe to one you just watched, that's vector search. When Amazon shows you products that are frequently bought together, yep, that's vector search too. But it gets even more serious. Banks use it to spot fraudulent transactions by finding patterns that are conceptually weird. Doctors use it to find similar patient cases to improve diagnoses. And of course, it is the absolute backbone of advanced chatbots like ChatGPT. Maybe the most critical use for vector databases right now is how they empower large language models. An LLM is brilliant, for sure, but its knowledge is frozen in time. It only knows what it was trained on. A vector database is like its personal, real-time research assistant. It's like giving that brilliant orator the perfect set of notes right before they go on stage. This whole workflow is called Retrieval-Augmented Generation, or RAG. Here's how it works. You ask a question. Before the LLM even sees it, the system does a super fast vector search on a private, up-to-date knowledge base. It grabs the most relevant documents, the perfect context, and then it hands all of that to the LLM. So the AI isn't just reciting from memory anymore, it's crafting an answer for you based on fresh, factual information. And this makes its answers worlds more accurate and trustworthy. So if you're a builder, or maybe just curious, you might be wondering, how do people actually make these things? Well, the good news is, this tech isn't locked away in some ivory tower. There's a whole ecosystem of tools out there for anyone to use. And the landscape is really diverse. You've got players like Pinecone, which is a fully managed service. Basically, you just plug it in and it works. It's perfect for big enterprise applications. Then on the other end, you have something like Chroma, which is open source and really lightweight, awesome for developers who are just prototyping an idea. And for truly massive web-scale datasets, you've got powerhouses like Milvus. There's really a tool for every job. And picking the right one just comes down to asking a few key questions. How big is your dataset going to be? We talk in millions of vectors or billions? Do you need answers in the blink of an eye, or is a little delay okay? Are you deploying in the cloud or on your own machines? Answering these basic questions is how you figure out what's right for your project. So finally, where is all this heading? I mean, this field is moving at an absolutely breakneck pace, and the magic library of today is really just the first chapter. Well, the next big frontier is what's called multimodal search. That's the ability to search using an image to find a piece of text, or use a clip of audio to find a video, all in the same system. We're also seeing this power move to the edge, meaning your own smartphone could do this kind of complex search without ever needing to connect to the cloud. And all of this is leading to a future of more deeply integrated and ultimately more autonomous AI systems. At the end of the day, vector databases are making a huge shift from being a niche AI tool to becoming fundamental infrastructure. Just think, every business today runs on a traditional database, right? Well, pretty soon, every AI-powered application of tomorrow is going to be running on a vector database. It's the new bedrock for how we store and access intelligent information. And that leaves us with a final and pretty profound thought. For decades, we've had to teach ourselves to ask questions in a way that computers could understand, using very specific keywords and weird syntax. But now, for the first time ever, the computers are learning to understand us in our own language with all our nuance. So what happens next? What incredible new questions will we finally be able to ask?